Hello everyone, my name is Maria McCavanagh and you're very welcome to this webinar. So today we are going to talk about Verv. So the mission of our company, which was founded back in 2009, is to reduce everyone's electricity bill down to zero, which is a pretty big mission, but I hope today I will convince you how we are going to do it. So think of today as very much a case study, and I'm going to talk through a kind of range of evolutions that we have gone through as a business. And of course, ask questions and you can just type into the box and I will answer as we go through, or if it's going to be answered later in the presentation, then I might just hold off for a little bit. So just to start off with the background of Verv. So we actually started back in 2009 when our founder, Peter Davies, had a consulting business at the time, and he was kind of doing a range of energy reduction projects for commercial premises. So think like hotels, coffee shops, any kind of big commercial premises where they have a target to reduce their electricity use. And due to his background in other engineering projects in the likes of Formula One, he attached a very high-speed data acquisition card to the main electricity source coming into these commercial premises. And he was sampling so quickly with this card, up to 1 million times a second, that he realized he could actually see when the security guard was turning the kettle on and the unique pattern of that kettle. And that allowed him to patent the technology that I'm going to talk about today. And I will talk about how we then moved into a domestic device. So I would just like to start off by also thanking members of the Verv team who have contributed to the content of this presentation today, particularly Lionel Ward, who is one of our data scientists. So he is our deep learning specialist, and also the rest of the team as well. As I said, my name is Maria McCavanagh. I'm the Chief Operating Officer. My background is in electrical engineering originally. I also spent some time in telecommunications consulting before moving into a commercial role managing West London and Surrey for a large test and measurement company. So just to look at our agenda for today, I hope it, as everyone was expecting, we're going to start off with learning how Verv started with an IoT device to give consumers greater insight into their energy usage, and then how we developed it into a blockchain-based data and peer-to-peer energy trading platform. So there are three main parts to the presentation today. We're going to start off talking about non-intrusive load monitoring and how it turns your home into a smart home with just one sensor. What is the blockchain and why it should be used for peer-to-peer energy trading? And then finally, GDPR, which will be more familiar to any audience members in Europe, and how it will pave the way for the ethical selling of data. So the first thing I'd like to mention is that we often in presentations think about the evolution of technology in isolation. So whether that be machine learning, we might listen to a presentation on machine learning and AI. We then might listen to a presentation on the blockchain and what it means, and quite often the blockchain will be focused around cryptocurrency examples, so Bitcoin. And then we might listen to another presentation about IoT, so Internet of Things devices. But actually these three technologies are all working together in so many different applications, and they're actually, the three of them are being referred to as the Holy Trinity now. And because they have worked together, the development has actually accelerated much more quickly. And so a kind of sideline of today, we're going to also talk about artificial intelligence and the crucial role that it will play in energy systems, and energy trading is of course included in that. So the first section then is the discussion on non-intrusive load monitoring and how it can turn your home into a smart home with just one sensor, and, of course, machine learning. So as I mentioned, back in 2009, we were focused on energy projects and sampling very, very quickly, and realized we could see the kettle or the toaster or whatever was being turned on inside the hotel. So the first question you probably have is, why is it taking so long? And basically, at that time, 2009, a recession was just ending. Smart home wasn't really, or rather, sorry, a recession had just begun. Smart home wasn't really a thing yet. We didn't have Google Home. We didn't have Alexa and things like that. And also for this technology in particular, very, very high speed sampling and the processing of that data resulted in very expensive hardware purchases. So it worked for commercial premises like hotels, like coffee shops, but to put that into someone's home would not have been feasible. So it wouldn't have been feasible to fund that. But with the advent of Raspberry Pi and other kind of high processing cheap computers, this was able to evolve into a domestic product. And why it is so much more interesting, or the machine learning problem is so much more solvable as a domestic product, is because I haven't met anyone who is listening to this presentation today. However, I could probably take a pretty good guess at the appliances that are in your home. So the problem is ring fenced. I know you're going to have a kettle. I know you're going to have a washing machine. You probably have a toaster. You probably have a microwave. And so the appliances that could be switched on in the home are from a short-ish list. And so solving the machine learning problem is actually much more simple than the likes of a commercial premises, where a lot of things are kind of large industrial-sized freezers, and a lot of things just look like heating elements, like resistive loads. So it's actually much more difficult and more bespoke to solve. So you need to consult in these projects rather than kind of scale up a product, which is what we really want it to do. So that's a bit of background to that. So now let's get into how it works. So you can see the Verv hub on the top left-hand corner. So as I said, it's very much a connected home product. It connects the device that you can see in the top left corner. It's about the size of a cigarette packet. And it connects to your electricity meter or smart meter, it doesn't matter, using a current clamp, which is very simple to fit. It's a bit like a bulldog clip, just clipping around the main electricity wire coming into your home. It then communicates via Wi-Fi with an app on your mobile device. And then this app is going to tell you much more information about the electricity use of your home. It's very much a global product. So all of the countries on this slide that you can see in the dark navy have between 220 and 240 volts and 50 hertz supply. So that means Verv works exactly as it does here in the UK in all of these countries in the dark navy. The lighter blue, so the likes of the US, we have a new product coming out in 2019 that will cover this area. So you'll just have to wait a little bit longer, unfortunately. So what are the problems that we're trying to solve with this device? So consumers are completely disengaged with their energy company. They spend 6 minutes a year thinking about it, and those 6 minutes are spent thinking pretty negatively because they generally don't understand why their bill was so high. Perhaps their direct debit was at the wrong level or something similar. There's also been a huge amount of danger caused by electrical appliances in the home. So forgetting about the faulty appliances, just leaving something like a hair straightener or an iron on causes house fires extremely frequently. So in the past 10 years in the UK, there's been 650,000 house fires caused by someone leaving hair stylers switched on, and I'm definitely guilty of that. In addition, we have appliances that go faulty and require repairs. So many people have taken out home care insurance policies. So in the UK, one of the big providers is British Gas Home Care. And this basically means if your washing machine breaks down, you can call the number and get an engineer to come out and fix your machine. However, 35% of the time, they have to come back again because they either didn't have the correct part with them or they were unable to diagnose the fault in the first place. And then finally, 60% of consumers don't actually understand their electricity bill. So if they have an electricity bill for the average is about £550 a year for the average household in the UK, if I ask someone how much of that bill was made up by your washing machine, they wouldn't know the answer in the vast majority of cases. They wouldn't know the appliances that cost the most. And we can see that through especially older people. I find my parents are always saying, switch the lights off, switch the lights off, switch the lights off. However, they're running a fridge in the garage that is from like 1990 as a spare fridge, and the amount that will be costing them to run will just that vastly outweigh anything they'll save by turning the lights off in rooms they're not using. So that understanding just isn't there, and that's what we're on a mission to solve. So let's talk about Verv's benefits then. So Verv will instantly recognize the devices in your home that are switched on using just that one sensor and little hub sitting on top of your meter or smart meter. It'll also show their running costs in real time. Verv will protect your home, so it'll provide notifications if you've left the hair straighteners or the iron switched on. And it can even tell you in advance if your appliance is faulty and needs servicing. So we can predict your appliance breaking down before it happens. We can also perform ROI calculations, so show you if there is a more energy efficient appliance and what the payback period would be to switch that out. And we do all this with an easy self-install device that can be posted out to you and you install yourself in less than 10 minutes. So, I appreciate that may have come across a little bit pitchy, which I definitely don't want to do in this talk. So moving swiftly on to the architecture and how it works. So you'll see we have a current clamp connected to the analog front end. So there could be up to 3 current clamps depending on if your home is has a 3-phase supply. So in the USA it's 2-phase, for example. Certain European countries will be 3-phase. So we have a different unit that has 3 clamps for that example. Obviously it is powered using just a simple kettle lead. And then we've got the analog front end and signal processing. Then we have data acquisition and any pre-processing, which also interfaces with the Wi-Fi modem and the Zigbee Bluetooth modem. And I'll talk to you, I've explained why we need obviously the Wi-Fi to communicate with the app. However, I'll talk more about the Zigbee element after. And then at the back end, we have all of our machine learning, where we have, we perform the disaggregation. So I probably mentioned disaggregation quite a lot in this presentation. Disaggregation is just the separation of appliances. So separating the washing machine from the kettle from the toaster. And we also have condition monitoring. So condition monitoring or predictive maintenance is where we're monitoring the condition of your appliances and predicting faults before they occur. ROI or payback is obviously what I talked about in terms of suggesting a more energy efficient appliance and the payback period that the saving would result in, and then obviously the system logic. So at this juncture in the presentation, I'm going to spend a little bit of time talking about the artificial intelligence and machine learning. For any of you who are familiar with these terms, this might be teaching you to suck eggs, but I will start off kind of back at the beginning. So feel free to ignore me for a few minutes if you're very familiar. So how the machine learning works for Verv is basically, as I mentioned, we sample very, very quickly. So we're sampling a whole range of data and then we're sampling current and voltage data at a very, very quick rate. And we can use that data to disaggregate the different appliances. So you can see on this graph that the toaster looks very different from the microwave, which looks very different from the mixer. Now, obviously, I'm sure you're thinking, I would never turn these appliances on sequentially. I like make my toast and heat up milk at the same time in the microwave, and I'm also making a smoothie in my mixer. So it's just for the purposes of the slide, we've kind of put them in order, but we can actually separate the appliances even when they are on all at the same time. So the analogy I like to use for this is if you think about if we have a microphone and lots of people speaking at one time, say in a conference room, we could sample that data and separate their voices based on the different characteristics. So, for example, a woman's voice tends to have a higher pitch than a man's voice. People speak at different rates. So I'm Irish, so I tend to speak very quickly. Different languages and countries will speak more slowly. There's different inflections in people's voices, and we can even tell if someone is ill because their voice changes. It becomes deeper if you've got a sore throat. So it uses the exact same machine learning technology as speech pattern recognition. It's very similar. So at that point, I will talk a little bit about artificial intelligence and machine learning. So the two terms are used very interchangeably. This bothers some people and not others. I kind of don't mind. And I hope that my discussion today will explain the difference between them. But again, I wouldn't lose any sleep over how you use the terms. So first of all, let's talk about why there is such a buzz around artificial intelligence at the minute. Well, basically, it's been around since the 50s. However, since 2012, there has been enormous leaps and effectively an inflection point, which there's kind of four main factors in why that has happened, which I am going to talk through. But this thing about artificial intelligence as human intelligence exhibited by machines. So what we see in science fiction movies, like the Terminator or C-3PO, is just general AI. So machines that have all of our senses and more, and we definitely can't pull this off just yet. What we can do is what's known as narrow AI, so technologies that can perform specific tasks as well as or better than we humans can. So a really good example of this is facial recognition on Facebook. So you can search for a person's face and tell if it's definitely them. And how do we do this? So the how of this element of narrow AI is machine learning. So machine learning is one approach to achieving AI. So machine learning is effectively a means of a computer exhibiting artificial intelligence. I hope that makes sense. So I mentioned I would talk about four factors and why there's such a buzz around artificial intelligence at the minute. So first of all, it's the algorithms themselves. There has been a massive change in the algorithms being used, particularly deep learning, which I'll go on to talk a little more about shortly. We now have these enormous flexible models that can learn very complex things when given enormous amounts of data, again, which we have a lot more of now. So previously, the machine learning pipelines had lots of blocks and stages, and there had to be human intervention in between. However, deep learning has allowed these long pipelines to go end to end through an entire machine learning system. So take, for example, photos on your phone. You can search on your phone for photos with mountains in, photos with cats in, etc. And deep learning is used to label that up. Second is hardware. So I talked today about the reduction in cost of hardware and why that was important to get the sample rates of data. But in addition to that, we also have much more computational power. So our machines have started off that our machines had more CPUs inside. And then we switched on to graphics cards, which were originally used for gaming, but you can use a graphics card like a whole farm of CPUs. And now we have even newer types of processor. So the incredible advances that computers have made means that the capability of the machine learning is much higher. Thirdly, data availability. So again, I'm sure many of you have heard of big data, and we all know through various scandals the amount of data that companies are gathering on us. And that's the kind of negative side. We've got the kind of GAFA, known as Google, Amazon, Facebook, and Apple. They have bought up huge farms of data because data is absolutely key to increasing the capability of machine learning, forcing that exhibition of artificial intelligence, which is what everyone is crying out for. It's why everyone has, an Alexa or a Google Home. And that data is so important to this development. The good side of it is that there is much more sharing of data sets with one another. So if we look at it from a more academic perspective, there's a lot of open source data sets which you can use. And I'll talk more a little later about one that we are using. And fourth, and probably most important, is the availability of expertise. With this kind of surge or inflection point since 2012, there has been a huge increase in interest in the last few years. So people studying STEM subjects are moving into AI and machine learning for their MScs, PhDs, etc. So in Verv ourselves, so we are a 50-person company, and we have about 15 employees with some sort of machine learning capability. And we definitely see really high caliber graduates coming out of MSc programs. So with this talent, the advances are going to increase even further. So I'll talk a little bit more now about deep learning, just because it is quite new. I think it'll be interesting to a lot of you listening. And I apologize that I don't have more slides on this, but it is very cutting edge for us. And this is kind of the first time we've gone through it in a presentation. But basically, deep learning models, as I've said, are the cutting edge in machine learning for pattern matching, classification, and prediction tasks. So the models themselves are trained using vast amounts of data, and given some sort of objective, will automatically learn to recognize a hierarchy of patterns, which will be used to solve the task. So take, for example, a model that is tasked with learning to distinguish between photos of cats and dogs. It will learn how to recognize different types of colors, hair, textures, fur, eyes, ears, maybe the nose, their faces, and their body shape. Subsequent layers in the model will learn higher level patterns and reuse the patterns which the layer below already knows about. So the layer that knows about faces reuses the eyes, ears, and noses detected in the layers below. So given enough training data, deep learning models can actually match or exceed human abilities to correctly recognize these patterns. And this has already been shown in very critical fields such as radiology. So one of the most exciting aspects of deep learning is called transfer learning. And this is where a model trained for one task can be reused to perform a different but also related task. For example, after training a model to distinguish cat and dog pictures, the DeepNet's parameters can be used as a seed for a model that analyzes videos for cats and dogs, which is going to massively speed up the development time, which is very exciting. So looking at how we apply deep learning at Verv. So we're specializing in applying the latest deep learning models to the energy data, as we've discussed. So it's used in our core algorithms for disaggregation and also the prediction of energy consumption in the future. We are obviously patenting these models and also have expertise in developing compact deep learning models that are deployable onto mobile processors, such as the Verv Hub, as we talked about, which in its first iteration was a Raspberry Pi, which is why I keep coming back to that example, as well as very large models that are deployable onto cloud services, for example, AWS. So our models that we've created are actually specialized for the high frequency data gathered by our Verv Hub. But we could also disaggregate lower frequency data from smart meters as well. And that's actually a good point I should have mentioned earlier. In comparison, so Verv will sample at up to 1 million times a second. The average smart meter samples once every 6 seconds. So it's just not possible to perform all of the smart home features that I've talked about with smart meter data, or we would just use that, because then we wouldn't have to put the hardware out, but it's absolutely not possible at those data rates. And then finally, transfer learning allows us to convert more and more of our pipeline to deep learning, so we can develop condition monitoring features based on our deep learning algorithms for disaggregation. So using our algorithms that separate out the appliances into washing machine, toaster, etc., we can then develop our condition monitoring features. So is the toaster broken, or is the toaster going to break on top of that? So that was just a brief segue into machine learning, and I hope it was interesting to you. Now on to a little bit more detail on how we can tell that there's a fault with the appliance. That's the question I always get. How exactly can you tell that the washing machine is going to break at some point in future? And the example I would like to give is on the drain of the washing machine becoming blocked, because that actually causes 40% of washing machine problems. So if you look at this graph, you can see we've zoomed in along the bottom, just above where you see washing machine cycle profile. So you can see the start of the washing machine, and then there's a change in signal where the door locks and the water starts to fill up. Then there's the water heater and drum rotation. Then we've got the washing cycle, where the drum's rotating, pausing, and then it rotates in the other direction. Then we have the drain. And this is the interesting bit. So as the water is draining out of the machine, if that drain starts to block, even by just a few millimeters, it's going to take longer for the water to empty from the machine, because it's a narrower tube that it's going through. So we're sampling so quickly that we can see that drain portion actually extend even by just a tiny, tiny fraction of a second. And then we can tell that there's some sort of blockage or obstruction has started to occur. And then we can alert the customer to this, so that they either clean it or they get someone out to help them. And then we can take corrective action before the drain completely blocks and floods the entire kitchen. So I'm going to speed on a little bit there. So I've mentioned the appliance fault detection and how it works. Also the ROI calculations. So I've told you about the payback period, and I've also mentioned safety notifications. We see Verv as very much the missing piece in the connected home. Quite a lot of people have Nest and Hive for their gas consumption. There's Alexa and Google Home for sound, and no one has really mastered the electricity portion of the smart home yet. And another point to mention is that Verv will integrate with smart meters and replace the consumer access device, which is the part that communicates with the little digital in-home display in your home if you have a smart meter. I'm not going to go into it much further than that, other than to say, you know, we do calibrate ourselves against the smart meter to ensure that the data you have is as accurate as humanly possible. So now we're going to talk about the blockchain and why it should be used, or could be used, in our opinion should be used, for peer-to-peer energy trading. So unfortunately, as much as I'd love to, I don't have time in this presentation to conduct a full discussion on the blockchain and what it is. There are tons of examples on BrightTALK that you can go and listen to learn more about it. But it's basically enough to know that the blockchain is just a ledger, like a spreadsheet, which records transactions. However, there's just one version of the truth which exists on everyone's device, in this case, in everyone's Verv. So think about your Verv just like a computer in your home. There's a spreadsheet on there that says how much energy you send to a neighbor. I'm going to go into how this happens shortly, and how much money they owe you and whether that has been transferred. And we basically have trusted individuals, so probably about 7 people in a 500 home system, that have the authority to verify the transactions and say, yep, that's correct. Alice sent Bob 7 kilowatt hours of electricity. Bob sent Alice 85p or whatever it was, and everything's all square. And the thing to remember is that the blockchain cannot be changed. So once a transaction is recorded on it, it cannot ever be deleted or adapted with because of this model. So you do not need a middleman. So in the blockchain, or sorry, the Bitcoin example, that's why you don't need a bank, because everyone can see all the transactions and who owes who what. In the energy trading example, you wouldn't need the middleman of a retailer saying, okay, this much has been transferred and this much money is owed back. The reason why we came across the blockchain and it as a solution for this project is we needed to keep costs to an absolute minimum. If we created a massive database with a load of servers in order to monitor and transact all of these different transactions between the different people in the system, we would be the middleman and we would have to obviously pay for all of that, and then that would increase the cost on the consumer. And as I said at the beginning, the whole mission here is to reduce electricity bills down to zero. So we need to find a way of saving costs wherever we can, and the blockchain is a great way of doing that in this example. So why did we decide to move into this space? So I hope it doesn't seem too far a leap from monitoring electricity and telling you how much you're using on an individual basis to moving into trading energy amongst one another. So how this came about is we did a project with 100 homes with UK power networks in the UK. And all of these homes had solar panels. And the Verv unit was being used to monitor the mains electricity, the solar panel, and the battery storage in these homes. So what we discovered through that project is that these homes were actually generating double the energy they needed in a year from their solar panels, but they just didn't have a means of storing it, hence they put battery storage in, or trading it to someone else. The only person they can trade it with is to sell it back to the grid. And the amount they get, and I apologize for using UK currency here, but it's all kind of relative anyway. It's 4 pence per kilowatt hour to sell electricity back to the grid. So the excess solar energy that you don't need, you will get 4 pence per kilowatt hour. However, you'll actually be paying 15 pence per kilowatt hour if you buy from the grid. So there's a 11 pence arbitrage there. And that is the area in which we are trying to start our first level of saving money. So I hope that makes sense. I'm going to talk further kind of into the example now. So at Verv, because we have the device in the home and we can tell what your electricity use has been over the past day, week, year, if you've had it for that long, we can forward predict your future demand for electricity better than anyone else. We know your patterns. We know when you have the washing machine on. We know when you turn your toaster on, tumble dryer, etc. We even know what you have on right now. So we know if it's the kettle you've turned on and you're just making tea or coffee before you go to work, or if it's the washing machine and you're therefore going to be using electricity for the next 2 hours. So that's the first layer, is forecasting the demand of electricity that you're going to need in the next 60 seconds, 60 minutes, 24 hours. In addition to that, if you have solar panels, we can predict what or how much energy those solar panels are going to generate by looking at cloud prediction. And this is where we've been using open data sets. I mentioned earlier about in academia, there are a lot of freely available data sets to train models on. So we can use cloud satellite data in order to predict how sunny it's going to be for the remainder of the day, and therefore how much energy is going to be generated by your solar panels. And then also, if you have battery storage, there are APIs that we can integrate with to find out the status and health of your battery and whether now is a good time to trade or not. So this has been very much from what we call a producer or prosumer perspective. So it's basically a producer-consumer. They both produce energy and consume it. And using these three things, so forecasting the demand of that house, what the solar panel is going to generate, and what's left in the battery, we can decide automatically if there is an opportunity to trade with a neighbour, i.e. there's going to be an excess amount of energy available in the day. Then from the consumer perspective, if they have a Verv device, they will know as close as possible to the exact amount of energy they need, again, in the next minute, hour, day, and can then make a decision to buy electricity from one of their prosumer neighbours at obviously a lower price than they would buy from the grid. And it's effectively a bidding system between the neighbours on who gets the electricity. Smart meter homes can also be involved in the system. They just won't get as good a price because they won't be able to make the trade quite as quickly or exactly the right amount that's required, because the prediction won't be as good, but absolutely integrates with smart meters as well. So I'm going to pause there in case anyone has any questions, because I appreciate that that is an area that might require a little bit more explanation. So there's been a question about privacy and how can one select which information they share with this grid, or I guess this system, what's necessary and whether you can choose what to share or not. So the last section of this presentation is going to be about data sharing and how we'll put that back into your hands. So I'm going to answer that towards the end, and please let me know if I don't answer it kind of effectively enough. And there's another question about a stationary bike and capturing the power and selling it back to the grid. So I'm not quite sure what is meant by that one, unless you mean kind of generating electricity using like an exercise bike. If you can store it, so I guess if you can get it into a battery, it could be possible in a similar way to the solar panels that I've discussed, although there's regulatory aspects to be aware of as well with that. So I mentioned the first project, which was about simulation and how we use simulated data in order to prove that there would be an opportunity to save 20% for consumers buying energy from their neighbours. And because of that simulation, we then went on to find a project and put a bid in for government funding for a project to actually do a trade. So the picture you can see on the top left is a housing estate in Hackney in East London. They crowdfunded, so on the right you can see the community. They actually crowdfunded solar panels to go on the roofs of the buildings. Now, these solar panels are used to power the communal areas, so some of the lifts and the community centre, which unfortunately isn't used very often. However, the people in the houses are unable to use the energy from the solar panels because there's no way of kind of accounting for it. So this community organisation are receiving 4p per kilowatt hour for energy sold back to the grid. However, the people living in these homes are paying 15p per kilowatt hour. And the really sad thing about this is that they see their energy bills going up and up, and there's actually a lot of people on this estate who are very much living on the line of fuel poverty. So they will find it very difficult to meet their electricity bills, and as the electricity bill goes up, they have to try and cut down elsewhere. So we partnered with Repowering, who are the organisation that put the solar panels in, to work out if we could virtually allocate parts of the solar panel to different members in the community and then trade the energy among them. So we have a 40-home trial, and some of the homes, so about 15 of the homes, will be allocated parts of the solar panel. So there are prosumers, and the remainder are the consumers. And we actually did the first ever peer-to-peer energy trade on the UK, on the blockchain in the UK in April this year, which was a big step forward in this area. And this trial will go on for another year. And we are also in discussions around kicking off other trials in other areas in the UK and also globally into Europe and Asia and the States. So we're really excited by this, and we do hope that we will end up in a place where there's a much fairer access to cheaper renewable electricity. So I've included, and sorry for the texty slide, a bit of a why blockchain. I already mentioned why we wouldn't use a database, because there would be the issue of still having a middleman or a third party to build and maintain it, and there would only be one version of the truth. So you would effectively be just putting another energy retailer in place. It also democratizes the energy environment, because we're providing an open framework for peer-to-peer energy trading that anyone could plug into. So it could be a battery supplier that says, do you know what, I'm going to go to a cul-de-sac and give everyone in that cul-de-sac a battery, and then they can trade their energy among one another, and they effectively take perhaps a cut of that to recoup the cost of the batteries. It's also decentralized. So the trading is completely decentralized, which reduces the transaction fees and admin, and keeps the price of the energy for consumers as low as humanly possible. Also, if you have a hurricane, earthquake, or flood, less likely, well, actually in the UK we have had flooding lately, hurricanes and earthquakes are less common. If that cuts you off from, say, the main grid, if your community is all connected with your solar panels, then it's still going to work, and the blockchain, of course, still works. There's also a very quick dissemination of information, so just one version of the truth. And then why Verv? So why use our system over any other? It's basically due to our disaggregation technology. So because we can predict the future energy requirements better, and also can predict the generation from the solar panels, we can predict demand better than anyone else and perform the trade at the most opportune time to get the best deal for both parties. Okay, so there's also been a question on cryptocurrencies. I am going to come on to that shortly. And now in the last section, we're going to talk about a little bit about GDPR and how it will pave the way for the ethical selling of data. So GDPR is the General Data Protection Regulation, which came in on the 25th of May this year in Europe. But it doesn't only apply to companies in Europe, it also applies to any company doing business here in Europe. And in the UK and Europe, or the whole of Europe, a lot of people will be familiar with this because there's been a lot of press around it. Anyone joining us from the States or Asia may be less familiar with it. However, I am pretty sure you're going to hear more about it as time goes on. So just a brief overview, it basically has resulted in personal data being expanded. So it also includes an IP address, for example, and any online identifiers. You must have explicit consent to use customer data. So here in Europe, we have had lots of emails coming around saying, do you still want to receive newsletters from us, etc. Facebook have had a similar opt-in around certain things as well. You must inform your customers if their data has been hacked. Customers have a right to be forgotten, so they can delete their personal data on request. Any breach must be reported within 72 hours. Information has to be stored in commonly used formats, so things like CSV, so that they can be transferred to another organization at their customer's request, free of charge within 1 month. Privacy policies themselves have to be concise, transparent, and easy to understand, so not pages and pages where in a line in there somewhere says we reserve the right to sell your data to whoever we want. And for non-compliance, there's a fine of up to 20 million euros or 4% of your turnover, whichever is the greater. So it's extremely serious and definitely, in my opinion, a good thing and something that should have been there from the very beginning. So in this last section, I'm going to talk about how at Verv we are proposing to use consumer data to reduce their electricity bill by allowing consumers to sell their data through a marketplace. So if we start off, if we talk about, as I said, an electricity bill, let's call it £500 per year. So by peer-to-peer energy trading, we're saying that we're estimating a reduction of 20%. So we're down to £400. Don't worry, I've got the figures, so you don't have to keep track of them. We can then perform automatic switching based on your electricity consumption. So if we know how much you're using and how you use it, what times of day, there are different tariffs for different times of day, we can automatically calculate how much better off you would be by switching to another supplier. And for that switch, there is an £80 kind of bonus for switching to another supplier, which we would pass on to the consumer. So there's another saving. So we're down to £320 now. We can then use the appliance home care data. So the fact that we know that your appliances are going to break before they break, if you give us permission to sell that data on your appliances health and condition to these home care insurance type companies, they can then use that data in order to contact you and say, you know, your appliance is going to break. We can come out and fix it for you. We have a subscription, say, of £10 a month to do this, or whatever it is. But that's your decision. And the price of that data is approximately like £30 a year. So for you to give that away. But again, the point is, this is your choice. And through our system, you will choose who you sell or show this data to. If you don't want to do it, that's absolutely fine. If it's worth 30 quid to you, then do it. If it's not, then don't. It's your choice. Home insurance then. Through the trials we have conducted with home insurance companies, we have learned from them that by having this information, so knowing, for example, that you're going to get a notification if you've left hair straighteners turned on, they would actually give you a bonus to reduce your home insurance. So because it's less likely your house is going to burn down with the hair straighteners being left switched on if you have Verv, then you would get a reduction there. So if you share your energy data with your home insurance provider, they'll give you a further reduction of £30 per year, approximately. Then the eco appliances example. So I mentioned earlier about how we can tell how efficient your appliance is and then make suggestions on more efficient appliances and the payback period that would result. So if you buy a new fridge, would you be better, if your fridge is faulty rather, is it better to fix the fridge or is it better to buy a new one, and what the payback period would be through the electricity saving for that. Obviously, the likes of Amazon and John Lewis would love to be the people telling you which appliances are the more eco-friendly for you because you're more likely to buy through them. Again, call that another £20 per person, so, or per company. So perhaps you say, do you know what, I buy everything through Amazon anyway, I happily sell it to them. Or you might say, do you know what, I don't like Amazon, Google, Facebook, Apple, having all of this data all the time. I don't want them to have it. I'm happy that with John Lewis, like they're a company I've always used and I am happy for them to have the data. So you can choose. And the great thing about GDPR is because that data needs to be able to be deleted at any time, you can actually change your mind whenever you want to, or you can say, do you know what, you can have it for the next 6 months because I'm moving house in 6 months, so I'll be gone and I kind of don't care. Or maybe you say, do you know what, I'm going to try it out for a month, see how much money I make off it and take it from there. So that's another way it can be reduced. Similarly, consumer purchasing behavior. So this is the bit that probably half the people on the call will say, oh, that's really cool, and the other half will say, oh, I don't like it at all. It's around how you use appliances that have consumables. So take, for example, your washing machine. Because the Verv knows how many times your washing machine has been switched on, it actually knows when you're going to need more washing powder, or your dishwasher when you're going to need more dishwasher tablets, your coffee maker when you're going to need to order more coffee beans. So this is hugely valuable to the likes of Tesco, Aldi, and maybe Walmart in the US, P&G, Unilever, etc. So this is another area. If you as a consumer say they're going to give you £30 every time or annually for sharing this data, if it's worth it for you, then fine. And if you don't mind them having it, then fine. If you don't want to do it, as I said, GDPR is there to protect you. You don't have to. And then finally, things that most of us won't care about. So things like demand-side response, and we're actually doing a project with Samsung on this. So if you take, for example, how in the home, there's a huge amount of demand at certain times of day. So for example, in the advert break of the World Cup or something, or Super Bowl in the States, everyone goes and turns the kettle on or goes and makes like coffees for everyone. And there's a huge demand on the grid, and it costs them a lot of money for that increase in demand, because they generally have to go and buy the electricity from elsewhere, the energy from elsewhere. So if you imagine in a home that has smart plugs, during that surge in demand, we could automatically turn your fridge off for, say, 30 minutes or an hour. Your fridge is so well insulated that it won't make any difference to the temperature of the fridge. And of course, you should receive an upside for this. So you should be paid in order to allow that automatic turning off happening, because it's saving a huge amount of money to the infrastructure. And again, that data, like that's kind of not something, it's not remotely kind of personal, turning a fridge on and off to most people. And in the same vein, because we're sampling the current and voltage so quickly, we can tell the quality of the power. So we can do what's called power quality analysis, which is hugely valuable to grid providers. So in the UK, it's National Grid that owns the kind of infrastructure. And that's very, very valuable to them. Again, you don't care, so you probably wouldn't really mind if that data in terms of how high the power quality coming into your home was, if that was being sold, because it's not personal to you. However, we believe that you again should receive the upside of that. It's your data, it's your home, it's your electricity data. So it should be your right to turn your home into this tangible asset, or this revenue generating asset, and again be used to reduce your electricity bill. So you can see there's a vast amount of data that we are gathering, we're being open about gathering, but all the processing is done in your home, in the Verv Hub in your home, and it is your decision who you want to sell it to, for how long, and if it's worth it to you. And our overall aim is to get electricity bills down to 50% by 2020, and then we'll work on our second 50% after that. So as Zaman mentioned cryptocurrencies earlier, to trade on the blockchain, you need some sort of digital representation of money. So you can't trade fiat currency as it's known, so pounds and dollars, on the blockchain. It's not physically possible. You've got to convert into some sort of crypto currency, or it's just a token. Just think of it as a token. So for that, we have developed a token called Flux, which is going to be used for our new energy marketplace, which has been designed this time for the consumer. So the Flux token will be used for the peer-to-peer energy trading and also for the data sales, which are going to be, the marketplace is going to be on the Ocean protocol, which anyone who is kind of in the space will have heard of. Again, I'm going to skip past this because I do not want this to be remotely pitchy. It's definitely about an evolution of technology. But if it is interesting to you, come and have that conversation with us separately. So at that point, there's just a few minutes left. And I'm going to just go back to the questions. Feel free to add any more questions, or if you don't have any, thank you very much indeed for listening. And yeah, so someone has asked about recommendations on which batteries to use for home use. So I'm afraid I can't answer that, because through our project, we have actually analysed 8 of the batteries of the biggest battery manufacturers. And I wouldn't be comfortable to make a comment on this because yeah, we're not kind of contracted to evaluate batteries right now, and our opinion is very much that we want everyone to have batteries to make the right decision for themselves, and the more homes that have batteries, the better it is. Someone has asked about the Telegram group. So if anyone doesn't know what Telegram is, just think about it like WhatsApp, but a bit more anonymous. So the group is called Vlux Official, so VLUX Official. You'll find it on our website as well. I'll just put that slide back up. So if you go to vlux.io, there's a link to the Telegram. And the question then, I'll just read it in full. Do cryptocurrencies tie into the peer-to-peer trading model here? Are they necessary for secure trading of electricity and money, or is it superfluous and someone could have the job of mediating the payments? So yeah, we definitely don't want kind of a third-party mediator. It depends what you mean by cryptocurrency. So I appreciate I went on to talk about the Vlux token after. We will have this token called Vlux, which is currently an ERC20 token, so it's built on Ethereum for now. However, we are working with the Energy Web Foundation on a new version of Ethereum that's suited better to peer-to-peer energy trading. I hope I've answered the part about, from a privacy point of view, selecting which information you can share. So it's very much going to be your decision. GDPR in Europe gives you that right, but anywhere else we go, we're going to use the exact same system. So yeah, and in terms of the information that's necessary to share for Verv to work, it's just the current and voltage data that we're gathering that we need to perform the disaggregation. And that is it. So came up nicely under the R, which I'm pleased about. I was worried I was going to go over. Would absolutely, oh, there's just one more question popped through, which is a good one, so I'm going to answer it. So given that the peer-to-peer energy trading blockchain is immutable, how will you deal with Verv customers that no longer want to be Verv customers and request their right to be forgotten? So that's a really good question. All Verv customers will, of course, have their right to be forgotten. We can delete everything. In terms of how it's recorded on the blockchain, in terms of the trading, you wouldn't know from looking at the blockchain the person's name, so there's kind of a level of anonymization which we then connect back on the home level. But yeah, that's a really good question. I'm going to add that to our FAQ on the Vlux website as well. So thank you very much, everyone, for listening and for your time. Do feel free to join the conversation on Telegram or through our website. Like, the contact us, there will be someone who'll be more than happy to get back to you. And I hope you have a great day or evening, depending on where you are. Thank you.